While I'm waiting for the parts to come in for the HP 9830A calculator that I'm repairing, I thought I might as well make a start on a new project. So this is the next in the list. It's a Mimi 803. I believe that Mimi was the name of the daughter of the designer. Just a rumour, I don't know if that's true or not. These are a rare machine, not many were made. There's not much information available on them. I don't have any software for it, and I don't know what condition it's in. I've just got it in for repair, and so I haven't opened it yet. Before I plug this one in, I want to open it, check the power supplies, and go from there. As far as I know, these were shipped with a copy of OCM, which is compatible with CPM. They were built very early 80s, 81, 82. I believe they have a 4 MHz processor, around 64K of RAM, and of course a couple of drives. And for the time, they were quite advanced. So we got pretty much a full keyboard, quite a nice mechanical keyboard. Bear in mind this was the era when the ZX80 and 81 were coming out. So quite an advanced machine. I've got no idea what these cost when they were new. If anyone knows what the price was or has any information, then please leave a comment. As I say, I haven't opened it yet. This is the first step in trying to restore it, repair it, get it working. The case has seen better days. There are a couple of fairly nasty cracks in it. I'll spin it round, we'll have a look at the back. So a view of the rear, we have power in, power switch, a couple of auxiliary out mains. Video out is on coax. I'm assuming that's composite, so we'll need some sort of converter to get that onto a monitor. Obviously a cooling fan, serial in out. I don't know what format these are in, whether they're standard serial or some bespoke version. No idea what this is. Strange looking sockets, and a reset switch, and that's pretty much it. It's very basic. What I'll do now is get the cover off, and we'll have a look inside and see what we're up against. Okay, so first view inside. It's apparent that I'm not the first person to have been in here. We've got a few broken standoffs. The board's not fully in place. A couple of the standoffs have been broken. They were sitting in the bottom of the machine. But quite a nice simple layout. A lot of discrete logic in here. We've got two lots of memory. One will obviously be for the video, and one will be the system RAM. We've got a few ribbon cables. This one goes back to the port on the back, as does this one. So I'm assuming that this one goes to the floppy drives. And then we have a little short link cable going to the keyboard. Power coming in, so very straightforward. But before I switch this on, what I'm going to do is pop the main board out and we'll test the supplies. Don't want to blow anything up before I've done the basic testing. While I'm at it, I'll also take out the ROM and read the contents, see if that's intact, and do the same thing with the PROM down here. I'm not quite sure what this is for, but we'll figure it out as we go along. But first thing, get this board out and see what state the supplies are in. Okay, so I've removed all the internals from the case. The case needs a lot of work. This machine was obviously used in a very smoky environment. The inside of the case is absolutely covered in nicotine, as is most of the internal electronics. So keyboard, quite a nice assembly. Another ROM that I need to read and get the contents, make sure that's okay. I'll go through this as a separate assembly and make sure it's working before I plug it back in. Then we've got the main board. It's in quite good condition. I've seen a few issues with this, but nothing major so far. One very nice feature is that every single chip is in a socket, so that will make life very easy if I need to start fault finding on this board and replacing any parts. Very strange something going on with that capacitor there, but But I mean, fundamentally it looks quite good. There are no sort of signs of physical damage. Again, it needs a good clean, but seems to be in fairly good order. I don't think a lot of work's been done on this, at least not for a very long time. A couple of bodge wires here, but they may well have been done at the time of manufacture. Quite a nice board, and especially for the time, it's quite an advanced board for the early 80s. Okay, so we'll get back to that. Now, one thing I was expecting with this and found, I do a lot of restorations of very old vintage computers, and in around 90% of them I see the same failure. And my advice, if you find an old computer or piece of vintage electronics in your loft and you want to sell it, don't plug it in. The reason for that is you'll almost certainly destroy something. Even if it seems to work initially, I can pretty much guarantee you that within the first hour you'll have a fairly major failure. And I see it in pretty much every piece of vintage equipment I work on that's been plugged in. That's why I never plug them in unless A, I know that somebody's plugged it in already, or B, I've taken it apart and examined it first. So this comes out as a single assembly. It's very heavy, which explains why the case is broken. This entire thing hangs from a flimsy part of the top cover, and top cover is just made out of fairly ancient plastic, and it's just cracked in several places, so not a particularly good design in that aspect. But what I found is, obviously we've got the two floppy drives, we've got the rear panel, and all very thick steel, so very heavily made. But in the power supply, I put the power supply cover off and found the failure I pretty much expected to find. So I don't know if this will come out on camera, but we've got the usual capacitor failure. So this is the spike suppression capacitor that sits across the mains input, and they will essentially do this every time. It's the same with these capacitors, and I think Dave over at EEV blog did a video on these fairly recently, and these will fail every single time. So in other words, never switch on pieces of equipment like this until you've gone through it and replaced all these capacitors. Sometimes they're hard to find, they're sitting within metal housings that you can't really take apart, so you have to replace the entire housing. It's basically part of a filter. So what I'll do is I'll replace this. I'll probably also replace the other ones. So generally speaking, there's one across the mains, and then there's generally one from each rail down to ground, and chances are at least the one across the mains has failed and it goes short. With any luck, all it's done is blow the fuse, but it may have taken out the bridge rectifier here that's sitting right next to it, and then I'll look at all the rest of the parts, all the capacitors, make sure it hasn't done any damage to anything else. The fuse isn't blown, so I'm hoping that everything kind of downstream of this is fine, but we'll have a look at it and see what we can find. One thing is a bit strange is we've got the mains coming in over in this corner, and so I'm assuming, judging by the state of this, which also is showing cracks, that this one may have shorted as well, although the fuse isn't blown. So it looks like a bit of a weird layout. I'll need to take it out and look underneath it and see if there's any isolation between these two sides. We've obviously got the low voltage DC supply here sitting right next to the mains, and then we've got the mains going down one side of the board back around, and I'm assuming it's going back into this section which is generating the low voltage supplies for the system. So I need to check all that out before I plug it in, and then we'll see if we can get this supply working, and then with any luck the rest of the system will work, but let's hope this hasn't done any major damage. So that's it for this video. In the next video I'll have this unit either repaired, or I'll go into more detail as to what the faults are, and then from that point we'll start investigating the main board and see if we can bring this back to life.